technical difficulties. One moment. Get our scuff out of the way right away here. Forgot a button. Sad piano to match this sorry state of affairs. There we go. So hello and welcome everyone. Welcome to the broadcast. We're going to be continuing our game dev project today. And hello Oleg joining us right away. Today's target is going to be positioning logic. So where things spawn from and how they're arranged when they spawn. So this is for things like spread patterns, burst fire patterns, those kind of things, as well as entities that spawn on random points of the screen, your vampire survivors, lightning strike kind of things. That kind of stuff we want to get in there. So we'll see if we actually start with that properly and if we actually get anywhere today. But before we do, let's check in with the kitties. Ember has taken up her spot across the keyboard. Sky is up in his tree. Then Mason and Sherbet are on the bed. Sammy is either on the bed as well or likely also on a little plush stairway that I put in place for when Sherbet was had hurt his foot. All right, but let's get in here. So like I said, we'll see if we get there. I've got to do a quick adjustment to blob movement, and I'll show you where we are currently. Look at our player factory object. I thought I had this. This, and we're going to return a vector 2. Okay, so then we can go to here, back to move to player, and get direction to movement rate is equal to constants square times speed delta that will be plus equals times movement rate. That's a float. Alright, blob should be moving again. So this is demonstrating the attack patterns that we have access to. Blobs are not moving again. This is unfortunate. So as I mentioned, this is the, we might not get to what I intended to get to. Why are the blobs not moving? Let's check their template. They move to player at a speed of 1 and a scale of 1. Move to player says, where is the player? given our position, then our movement rate. We have a vector, we have a movement rate of 3.2. And to the target movement, we are adding... Oh. 2 player times movement rate. And here come the blobs. There we go. We are spawning 3 projectiles every half second, each with their own movement pattern, sometimes composite patterns. And we are spawning 1 blob a second. Might be every half second. So we're spawning quite a few entities a second. And we're maintaining it right around 60 frames a second. Dodd, I don't know if it will be multiplayer. I am trying to rig up the system so that it would be capable of handling it if we do. But at the moment, no. We're trying to make it so it would be possible, but not. It would be possible if we go down that road. But yeah, this is where we left off. We have the sine curve, we have the spiral, and at the moment, we're using move to the right to drive this projectile to demonstrate something. If you watch the sine wave curve here, it goes sine wave, but the curve happening, each of these blue ones lines up perfectly with one of these purple ones. Each of the blue and pink ones also lines up perfectly with one of the purple ones. How about now? Okay. Every now and then. But, so, the rate that the spiral expands in the lateral movement, or at least the directional movement of the wave, is equivalent to just moving in the direction that it's going. So, hooray, we've got that. Then, if we go into our game, we're going to limit it down to a single projectile here. Well, actually, we are going to... So this is our default yarn ball. Actually, no, this is our slime. This should be the default yarn ball. Hello, cat. Hello, everyone. So here's our spiral movement for template 2. Right now, spiral movement doesn't move. It is a personal question and also relatively rude to just begin with that, cat. Does it matter? Does the sexual orientation of the robot cat matter to you? Okay, so we're going to add speed. Here's our spiral. We're going to reduce the spiral's rate of growth by 2. Now, this is the speed of rotation. So we are going to have the speed to the right and have the speed there. So we're going to make the spiral move to the right as well. So you can see the spiral is stretching right, but it's still hitting the same points because it's stretching right at a rate of 0.5 and also expanding the spiral at a rate of 0.5, making the net rate 1. So we're still getting the same expansion in a direction. Now, the curve is still moving at a rate of 1. So what this is showing us is that we can stack these without really causing much by way of performance impact. Okay, so this is the one that moves to the right. This is the purple one. So we're going to show how this do. We're going to have 4 move rights. And each of them is going to move right at a speed of 0.25. Just so. So if we look, they're still moving at the same pace. We're also doing 4 times, effectively 4 times, the calculation here as far as how they're moving. No real impact. This is where we wanted to get to. The blobs are also always calculating where the player is in regards to them. It's not a super expensive calculation, but it is an extra calculation per frame that is happening. We can make it so these move in random directions. You can't really tell how they're moving as easily when that happens. But it's pretty good. It's pretty good. Okay, so now we need the concept of positioning the projectiles when they spawn. Originally, what this did is that the spawner would look at the positioning logic, take all of the projectiles that were going to be spawned, spawn them all at once, and then rearrange them and adjust the direction of them accordingly. We can still do that. The difference here is that we don't want to spawn them all at once. We want to spawn them quickly, but not all at once. Reason being for that is that if I spawn too many things simultaneously, we start to get some performance hits. It only really starts showing up when we're spawning like double digits of them. So we need to be cautious of that kind of thing. So I think the one to start with is an on-off kind of pattern. All of them are actually going to have this pattern, and that's essentially I'm going to start firing at this point. And as of this tick, I'm going to fire enough of them at this rate. So let's say, for example, you have a burst. And that might be, I'm going to spawn 3 of them. They're going to spawn at a rate based on an incoming speed value or something like that. And then there will be a pause between the next burst. So we have a number to fire. We have a sequencing factor. And then we have a downtime between them. And think we can go with that. So we have the concept of movement in spawning. We're going to move movement out of behaviors here. And where am I putting the spread pattern here? Ah, okay. We'll fix that in a moment. So now we have the concept of position modifiers. I think we're just going to call this positioning. We're going to keep this around just to keep track of it, at least for its code usage. Okay, nothing's broken yet. So it's going to extend... I mean, it should extend nothing. Okay. Sadly, it has to extend something, I guess. Yeah. Leave it as object empty there. We're going to call it positioning. We don't want to call it something like position. That will be confusing. And I don't want to be overly verbose. Hello, Rabab. Welcome. Okay, so then we're going to look for our positioning object here. It's not going to extend node. It's going to have a class name of positioning. So we have a function. So we're moving spawning out of the spawner. This will be part of it. It's going to use the incoming template to tell it how it should do this. Making sure we haven't further broken anything. Okay. Hello, Ember. Okay. Let's look at our existing one. We are going to close everything but positioning for now. And we're going to look at our spawner. Should be right around here, yeah. Currently, we're using a collision zone to spawn into. Because the positioning logic is going to determine some elements of the entity, but we don't want to spawn the entity unless the right amount of time has passed for it. Hello, cats. Initialize the new entity. We've already got position. Okay, we have a physics tick. We're determining the position right here. That's going to get moved out to part of positioning logic. How are we going to do this? Because in a way, we want to be able to cascade positioning as well. So for example, you could have a three shot burst, and each shot is a spread shot of, X number. That does create... I will probably not do so, Sans. So how we do this? I have one bit of logic that determines whether we should spawn. And that is each of the positioners would be able to say whether it's time to spawn. And each of them would cascade if that happens. Okay, we move frequency out of the idea of positioning. The spawner itself will still control frequency. It is the positioning logic after that that would control how that is going to happen. So a 3-shot burst is a burst positioner that will say, okay, I'm going to spawn 3 things, and those 3 things will be in sequence. If there's a subsequent positioner, then that trigger for a spawn gets passed to the next thing and says, how should this be positioned? What should happen here? So if there is no actual subsequent positioning logic, instead of calling into it and saying, okay, now do your thing, it will instead trigger the spawn of an entity. So in the spawner, we have this spawn lump here. This is going to get relayed along. Positioning is going to be determined by the spawner itself. So in general, the first positioner will be things like on player or at random position kind of stuff. Then the movement pattern of them will be determined from there. After they're ready to be spawned. That does create an extra wrinkle here for the purposes of spread shots, but I think we can still adapt to that. Because each thing's movement could have some incoming to it. Ha, that is indeed a cute kitty, especially Sherbet tends to play for the camera a little bit with how he'll shift around and be kind of cute. Let's do a cat check. A lot of people have come through here. Apparently it is bath time for Sky. And Mason and Sherbet are snoozing, as we saw earlier. Ember is on my lap getting some back scratches. Sammy is MIA currently. Maybe she'll show herself a little later. Okay. Some spawners will set the position of it. Some spawners will set... Some spawners will set a patterning to it. They won't change the target, but they can produce a direction. And that direction should be passed into the subsequent movement chain when an entity moves. As in, the initial direction should be set that way. That may have no impact on subsequent movement entities, because if, like, target random direction is set, then it's going to ignore a patterning movement. So a forward spread shot that has used random direction is not going to look like a spread shot. It's going to go everywhere. Hello, Don. Okay. Spawn can return an entity. What do we do with that if we spawn them? We do nothing with entity if we spawn. But if we trigger spawn on the interval, if the physics tick triggers a spawn, we're always going to create an entity. So the end of a movement chain should still result in all of this stuff changing. Position needs to be determined by the positioners. Let's start commenting this here. In sequence. As in the entity, let's get that loaded up here. Entities store off a target entity in a target direction for them to remember moment by moment and pass that back into the movement loop. Just gotta hit a couple buttons, folks. There we go. We have a moderation principle. There are some statements that are going to potentially result in me warning you that something might be inappropriate or too personal or something like that, or you're just being annoying. We also have the zero to rude or creepy principle, and that's that if the first thing you do when you enter chat is be creepy or rude, then the likelihood for tolerance or for a warning decreases wildly. So when an entity is moving on its physics tick, we go through all of this. So if we're setting target direction coming out of positioning, then we're good there. So we could iterate over the movers or the positioners and ask, okay, which I acknowledge you still, Amber. I do. Hey. Some of them use their hind paws to scratch their chin so enthusiastically that they'll get little cuts and scabs there. And I always try to make sure that it doesn't clot up their fur too much. But they really don't like that. It's kind of a balance because, if you damage the scabs too much, you'll hurt them again. Like I said, you don't want it to choke out their fur or anything like that. So it's that balance of making sure that they're not getting too grubby or getting food caught there kind of stuff. Ember is one of those kitty cats. Her and Sherbet are really prone to that. They're just little kitties. Their hind paws are ever so sharp. Okay, so a positioner should have a get direction. Oof. But that's not quite right. That's not quite right, because the positioner then would need to know how we're already moving. So to return to a prior one, I actually don't want a spread shot to spread in random directions if it is if we get random direction as the first movement, the entire spread should radiate out in that random direction. The burst shot should all go out in that random direction. Hello, Madison. Welcome. So, when the entity is initialized, okay. This is when we initially spawn something. This is tricky then, because it's at this moment, right here, that we determine initial movement behavior of the entity. And currently, it is right after that where we set its position, because when we spawn, we're telling it that. Positioning should be determined by the positioning logic. Shocking, I know. So ultimately, we won't pass this in. This will be part of the entity initializing itself. Each one of the positioners being used, though, needs to have remembrance of prior ones. So positioning is more about the spawner. And right now the entities are controlling some degree of their movement. The first entity in a spawn cycle, we need to understand how it's moving. I don't, Jackson. Please don't take offense if I don't remember somebody, but it's gonna vary whether I remember somebody. The frequency and type of interaction will generally determine that. Your primary interaction is asking if I remember you. I'm probably going to forget on a regular basis. Not as a penalty of any sort or anything like that, but more as it just doesn't lodge in my brain. Sammy has come over for pets and is obstructing the keyboard. Sammy has mostly forgiven me for her recent vet visit. She resented that for a couple of days and was being very cautious of my presence. She just needed her yearly checkup. I will be traumatizing them all again in a week or two, a couple weeks, in order to get their follow-up vaccines. Okay. So we spawn the first entity. That would get us basic movement direction as we create it. When the entity is initialized, we set its position early. Because we're trying to get some degree of direction to it. But we don't know the position until we call into the positioners. Oh dear. Because some movement is going to rely on which direction you're gonna... what spatial orientation to things. So if I call like targeting and say I'm aiming at the player, and something says, move in a straight line towards your target, then the fact that I have targeted the player, the direction to the player is dependent on where I am to draw that line to the player. So if I don't spawn at a given position, I won't know. So the first thing that we have to do is ask the spawners about positioning. Is it going to be on player, or is it going to be on a random position? Is it going to be on the spawner? That will get us our position. So we iterate over the positioners and ask them, do you set the position, the starting position? Because if they do, they can cascade that along. For the most part, we're gonna have two. Probably three. One is on the world spawner, so off the edge of the screen where the blobs come from. We're gonna have on the player, where most projectiles will spawn. Hello, Maximum. And then we're gonna have random position, which will be somewhere visible on the screen. So once we have that position, we can proceed into the rest of the spawning logic. So we get the position from the positioners. We pass that in to the first entity created. So as part of a spawning sequence, we need to know which entity we're spawning. We can call over each positioner. No, we know we're spawning something. Each positioner will have its own number of things to spawn, and we'll keep track of that. So the spawning logic does need a position to get. We're making a game, Bricks. Let me show you where we currently sit. We've got some testing logic in here. These aren't all of the final graphics, but they're some of the graphics we intend to use. This is a survivor-style game, so the general idea of projectiles get launched out in all kinds of directions here. And, you know, you get rid of the enemies before they get too close. We can move around. What we've done is we've created some logic that lets us piece together this behavior that they're using based on like a series of parameters. The purple balls are being moved to the right 1/4 normal movement 4 times in a row. The sine wave is not actually moving to the right. It's just taking it's just adjusting what it has based on this curve. And then the spiral is actually moving to the right 1/2 a unit and then spiraling out 1/2 a unit. So we get this kind of leaning right kind of pattern. It doesn't have a formal name like a final name yet, Maximum, but the working project name is Nyanite Survivors. I don't know what it will be called when it's done. Hey, I have new drivers ready. Okay. So the spawner is the one that owns the positioning. I can't really tell what that image is. Are you using a tiny version of my avatar? There's some hint of that, but I could be mistaken. Okay. So if a spawner has created a first entity, so if positioning has not yet happened, then the positioners will have stored off that it has not yet happened. They'll store off if it has begun happening, and they'll store off if it's done happening. Because it can take multiple physics cycles to finish a single spawn event. We're probably going to start trying to do it all at once first. And then we're going to start, if that doesn't work for performance, we'll do it in cycles. We need to be careful of spawning too many things at once because they can interfere with each other. Okay. So first we get the position from them. So something like for let's change this. This is a positioner, and we shall rename you I will eventually probably change movement objects to movers. Okay, so positioners don't actually... Should they spawn? Because the positioners just give me the individual patterns to spawn them on. The goal is to make it available to the public in some fashion, Maximum. And hello, dog. Okay. So they're going to call where to spawn it. They're going to call a direction. And they're ultimately going to control whether a spawn happens. because the chain will tell a given spawner whether it should keep spawning. So each spawner will ask the subsequent spawner whether it is spawning, and that will propagate up the chain. Jamal, hello. That's 2 of 5. Let's see how many we can spot, huh? I think we're going to get all 5. Is camera 1 going to behave? There it is. So we have Ember across from the keyboard. We have Sky up in his tree. We have Mason on the blanket and Sherbet on the pillow. And then we have Sammy over on the shelf. It is apparently bath time for Sammy. Okay. Position and positioners do a thing. Position to use. Position to use. Ah, my fingers are offset. So in a way, having the positioners set up to be a daisy chain of them instead of a series of entities. Nope, we have live video of the cats. There are 8 cameras spread out through the area to try to keep one on camera at all times. So we don't want to recreate the spawner chain each time, or the positioner chain. Okay, so we're going to pass the entity template. We're going to use the entity template to create a chain of positioners. So what that will be is we'll from a practical perspective, almost do it backwards. We go through each one and say, okay, you exist, and now you are the child of the prior one. You are the child of the prior one. We could do it recursively, but that's still kind of messy. So I'm figuring we'll go through it backwards. Get that positioner, instantiate it, attach it to, then use it to pass into the next one. If a positioner doesn't have a child, it'll just stop the chain. So then positioners, these don't actually spawn an entity. And each entity will have the initial movement passed in. It will be based off of the first movement passed in. Then all subsequent ones can remember that. So we get an initial direction from the first entity created. We pass that into the positioner chain, and And the positioner chain is going to remember that information for the entire cycle of the chain. So if the first entity that spawns in a group gives us a particular bit of directioning logic, that positioner chain will obtain that and it will keep it. And it will use that for the rest of it. An artistic team competition. What's that mean? So they have a function. Turns a bool. For the time being, we'll do that. I don't know what BFDI is. And hello, dude. Positioner is a positioner. I mean, recreating Solitaire, I would probably use a lighter weight engine unless you're going really bonkers in some way. Like, you want to use some over-the-top powerful graphics, or you just want to learn one of those bigger engines. But like Godot or Unity or any of the other smaller packages, there's like Game Dev Studio, that kind of thing. Sky's the limit on those. I'm not a fan of Java myself, so I would never suggest it. The language that you're going to end up using is going to influence which systems you could use. I would advise some sort of engine to drive like the visuals of your game. You could do it with like, pure text or something like that. But, for example, if you want to use Java, then Godot engine won't really be an option, because Godot engine uses GDScript, C#, and I think you can get away with something like raw C-level interaction, which means you wouldn't be able to use Java if you wanted to use Godot, or if you wanted to use Java, you couldn't use Godot. I would say that the programming language is often a choice that would happen after picking what kind of game it's going to be, and then what engine you'll use to accomplish that. So since you're saying a card game, if it's just cards on screen, just about any engine will do. If it's more than cards on screen, then a little research to verify what kind of graphics or similar an engine is capable of would be the next thing. But past that, there's a lot of flexibility. I chose Godot over Unity because I wanted to try Godot in the aftermath of the whole Unity PR debacle. let's see. They say whether they should continue spawning. They're going to have a get position, which is a function that returns a vector 2. Vector 2, 0. So the rules are different and similar. That doesn't really matter, but the multiplayer matters. Some engines have really good built-in multiplayer functionality. Some of them you might be winging it, and multiplayer netcode is not simple unless you have packages that do it for you. I haven't heard anything about the Unreal Engine. What, does it have some sort of, like, internal variable naming censorship or something like that? For example, with Unity, Unity has a lot of baked-in logic for creating a server and connecting to a server, as well as for creating multiplayer-controlled entities. Like having a client call out to a server and say, you know, give me my character reference, or this is me, so that communication can be handled. I don't actually disagree with that kind of thing, Dodd. I've actually changed my my own code repos not to use like master slave. It's essentially terminology that, while it is that it had been used traditionally, it doesn't need to be that, and that set of terms doesn't convey any extra information. But those terms do have very racist history. Some of them being racist history that is still impacting today. Orphan, I don't know, but I wouldn't disagree with it if it was done. Do you understand what blacklisting meant? You know, why it's called blacklisting? Like, the mechanic is fine. They're not saying remove the mechanic or the concept. What they're changing is terminology that perpetuates some of those concepts. So the term master isn't really what they're changing. They're changing the pairing. Right. The blacklisting and whitelisting was, like, by its nature, was indicating these are allowed and okay, and these are bad and not allowed, using the racial modifier. Like, the action is something that previously existed. The use of the name is what has is the problem. And even if it previously existed, the language was co-opted. It's kind of like the toothbrush mustache isn't an intrinsically evil thing, but history made it something that is something you avoid. Okay, so the positioners, you're going to call get position on the chain to verify whether where something should appear. So each one of those is going to call current position isn't really the terminology we want to use, because current position suggests we already have one. Calling into get position is saying, what should I be using? We're still going to do it. I think it's it's when we initially pass it in, we don't have one yet. And then we're going to call next positioner with get position. Why can't things work in the first try? That's a bit of a programming mantra, isn't it? If next positioner, then I don't like this pattern, but we're doing it anyway. By default, like in the parent class, mech, it's twofold. It's you have the learning operation and the execution operation where you can make mistakes in a language or you're doing something wrong. There's the planning stage of it where you have a bad plan, or your plan doesn't do, like, the plan is broken in that it can't accomplish what it is, or it doesn't exist, or the execution of the plan doesn't work. And that just daisy chains down the line. It's a learning process, and messing something up in coding is almost constant. Anybody that professes that they never make coding mistakes is lying. It's in the same way that if somebody says it's just a little change, we don't need to test it, they're wrong. That code will detonate on impact with production. It will bring down your whole system. Mech, yes. I'm saying that should be considered the baseline experience. Is until you learn it, you're going to spend a lot of time trying to figure out the right way to make something work, the correct way to make it work. And then even if you know the correct way to make something work, the something you're trying to make work might not actually be the something you want. So, like, right now I'm puzzling out how to make this class. This is the second time we've made this whole concept as a class. We're starting again from the beginning. And Don, I don't know who that is in the Unity community. Ha, rhyming. Perhaps we'll find out more after a quick break. If you haven't already and you like what you're seeing, remember to like, comment, and subscribe and all of that goodness. And I'm back. Let's see. Mac, one of the big things that I would suggest, especially if you're doing your coding offline, like I'm coding online in front of people, but especially if you're doing it offline on your own time, there's no crunch, anything like that, is always have a document or a notebook or something like that where you articulate what you intend to do with something. This is your design document where you write down or just try to visualize how different objects are going to talk with each other and what they're going to do. And then subsequently you try to execute on that. That way you're not going into an object trying to think, what was this supposed to do? What did I want it to do? Pretty much like you're seeing right now. What I'm doing is seat of the pants rubber duck programming. I have ideas on how I want it to work. I have a structure in mind. I have technically done that design up front, but I don't have all of the logic already plotted out. I will generally translate a statement once. I only speak and read English. So hello, glue. When I say it's rubber duck programming, rubber duck programming is a kind of a code flow methodology where you are explaining and justifying what you're doing as if you're telling somebody. The joke or the gimmick of it being that you have a rubber duck on your desk and you explain the logic to the duck. The duck's not going to respond, the duck doesn't understand, but the point is that by articulating it yourself, it gives you an opportunity to say, wait a minute, that's wrong. Hello, Sky. Got wet food out there, and Sky always wants me to pour kibble out with the wet food, but I try to hold out on that as long as possible until he becomes a real problem, so that he'll eat more of the wet food. Because a few of them are getting kind of chonky. Not like full overweight, but they're gaining more weight. Okay. So this is pretty much common. You can technically intervene in this. You could have a positioner that says, I don't care, I'm overriding this. That should never be the case. We could ask backwards. Okay, if I ask if I should continue spawning, the pattern is to always ask the next one until there isn't a next one. If anything else in the chain says it should keep spawning, then the answer is yes, continue spawning. What this does is the last one has the final say, because it's the final one. But for example, if we go back to our example case of a 3-shot burst that fires 10 pellet spread, then if the 10 pellet spread is still creating those 10 pellets, if the 10 pellets are still spawning there, then we don't want to stop spawning pellets. Once the 10 pellet spread is done, if the 3-shot burst hasn't done all 3 yet, it's going to say keep spawning. Once it continues spawning, it's going to hand control back over to the 10 pellet spread, and the 10 pellet spread will subsequently say, oh, I'm still spawning because I have 10 pellets to do. And we will continue iterating on that. Each individual positioner will have its own thing. So this, I think this is a fixed thing. All of them will use this logic. We could encapsulate an internal is spawning function. I think we're gonna. Okay, so the idea here, this is a universal function. This should always stay how it is. Is spawning is internal, and this is the one that child classes will override. They might just have a Boolean that they keep. They might have any number of other things. Don't want them to be named the same thing. We're just going to call it position to use. It should be a get. It is a get. And then we don't just return that, we do this. Okay, so this is another... These are not supposed to change. Always a positioner will call down the chain until it has nothing, and then it will return what the last one in the chain says. We could actually do this in reverse, is always ask the first one. But each one of them is going to determine that. So if one of them comes in and is told to start spawning and it's not spawning anymore, oof. Okay. Let's talk through this a little bit more here. That we're fundamentally changing the sequence of events during a spawn. A spawner will have an interval that says, I am triggering a spawn event now. So right now we have, here, let me show you. Every half second, we're spawning a blob, we're spawning these 3 different yarn balls here. They do their own thing, but every half second that's happening, and what currently goes on is we just outright spawn it. What we want to do is have 2 different states. We're going to say, am I currently spawning entities? Or am I in a delay state? So if it's a delay state, it's not going to spawn anything else. It's not really going to talk to... it's not going to trigger a new spawn event. But if the spawners say keep spawning, it's going to... or the positioners say we're still going, then we have to continue to consult them and continue to spawn entities. So the first thing we do is we call through them and say, get the position that I'm supposed to use. We're going to do... Okay, each one of them will have logic to start spawning. But we need... It's not... Then we're going to call an internal function. We're going to use this. They're the same. This is the internal version. Don't know that I like that pattern, but... So this is another fixed one. We call into start spawning. Each one will tell all of the subsequent ones they should start their spawn logic too. So this preps all of them. In the case of, let's say there's a 10 pellet spread. 10 pellet spread says, oh, okay, I'm on the first pellet, I have spawned this many pellets. Then the 3-shot burst says, okay, the next one is ready. To get ready, I'm going to say I have 3 more shots to spawn, and I have spawned 0 of them, you know? Or I have spawned 0 already. However we want to do it. Maybe each of those, maybe the 3-shot spread has an internal cooldown as well, where it's like, this is how long it's been since the last one that I triggered. Then we just keep chaining back. So we've started spawning. So all of them at this point are probably going to say true to this. But how they say true to that is going to be different. Then we're going to ask, should we continue spawning? And that's going to be each one can return is spawning itself. But if anything down the chain says true, then it reports true. Oh no, this isn't right. So this is what I was talking about by rubber duck programming. Is by speaking it out loud, by talking out loud to myself about it, I'm causing myself to rethink how each of these steps will work, and if I spot something wrong during that process, I can intervene and prevent an error from going down the chain. If there's an next positioner, should continue is equal to this. If not, should continue is equal to is spawning. Then we return should continue. Continue. Okay. So by default, we don't continue. If there is a next one down the chain, we're going to check and see if it says we should continue. If it doesn't, oh, okay, no. If there isn't a positioner, this is interesting logic. Okay, so if the positioner says we should continue, the next one says we should continue, by default, we're going to report that we should. So if we don't, we're going to check ourselves and say, should we continue based on that? Based on what we know. If that's true, we're going to tell the next one, you should do it again. You should start spawning again. Because we're going to start spawning again too. We're going to continue spawning. So that will reset the next one. So in our example, the 10-shot pellet spread has fired. So we have a spray of 10 pellets, the classic arc of pellets. Then it's done. It says we don't need to continue. So I check. I've done one spray of them. This is the 3-shot burst. Now it's going to say, okay, I have 2 more parts of this burst to go. We should continue. And because we should continue, second. There we go. We don't want to say start spawning if the next one says we should continue spawning. So if the next one has not said we should continue, I'll check myself. If I say that we should continue spawning, then I tell the subsequent ones they should start spawning too. They should resume spawning. In a similar vein, when we're positioning, if the next positioner exists, then we're going to call into that and get what it says. Otherwise, we're going to return what we say. The final one always has the say. Okay. And by default, start spawning does nothing, is spawning is false, and position is always 0. Yes. Okay. So in a spawner, we're looking at our physics tick. This is the spawner is being told, do a physics tick. Doing it this way is going to let us put spawners in a global collection. This is good. We get a time since last tick. If the interval says that we should be spawning, then we're going to start the spawning process. The entity position is now going to be determined by the positioner chain. Okay, then positioner chain is also going to be started here. Right. So what this logic is going to do initially is it's going to create all of them at once. And there always needs to be part of a positioner chain, or this is going to explode. This is essentially throw an error if this is not true. I could make this a constant. That's more efficient. We're not going to yet. So we start spawning. Say while positioner chain dot continue spawning. Do this. Hey, G-Man, welcome. We're doing some coding. Thank you. It's a good excuse to look at the others. Sky and Ember are snuggled up across from the keyboard. Mason and Sherbet are on the bed. Can't see Sammy right now. Okay, so until we're completely done spawning, we keep doing this. This is definitely a hack, but we're going to keep this in place until we have the first positioner created. So this is where it spawns. This is the template to use for the rest of it. This is which zone we're putting it in. So we need a positioner to start testing this stuff. So let's make the first one. Spawn patterns. Our turns. Patterns. At most, I will thank you, G-Man. There is no sort of obligatory shout-out process, but I do appreciate any subs or likes or the like. Well, thank you. Okay, so we need a spawn position. Create a script that inherits from a positioner. This is going to be this is weird terminology. Let's see. We're not going to say spawn. We're going to say spawn on the spawner path. No worries. Thanks for swinging through. Okay. Start spawning does nothing with a spawn position. Doesn't care. Continue spawning will always return false. So unless something subsequently says I should spawn, it's going to say no, don't. Oh. Boolean is equal to false. That's a variable, not a function. Oops. Okay, so spawn on spawn path only has a currently spawning once. After it has been called through to spawn once, it stops, and it resets it to what the subsequent ones care about. No, it's always done. So here, look. So this one says spawn somewhere random. Okay, no, I see why I was doing that. It says currently spawn. No. Okay. This spawns on the spawner path. This is what blobs will use. It's told to start spawning. It tells all of the subsequent ones in the chain, hey, you should start spawning. So they start doing stuff. When we ask, is spawning, this one says false. Okay, this is where we need get position, is spawning, and start spawning for there. It needs to spawn at least once. This one says only once. That's all I care about. Spawning once. We get position. So we report we should continue spawning. We start, that one says, yeah, keep going. Anytime we say, are you spawning, it's going to return its spawn position, or its current. It's going to return spawning. We have to do this right here. So we're told you should start spawning, so we say so. We are currently spawning. Then when we ask, are you spawning, we are going to return that value. Say Boolean that is equal to spawning. We're going to return should spawn, and spawning is false. If you ask this one, should it spawn? This one in particular, it will tell you whether it is right now. But once you have asked it, is it spawning? That ceases to be true. Let me see if that flows. When that one is alone, that will work, because we tell it to start spawning, and then when we are doing our spawning, we ask, should we continue? Which will go into this, and we're saying, should you continue? So we're going to ask the next one in the line. If the next one in the line says true, we continue. How do we differentiate here? So when we actually do the spawn, we have a starting position, and we go through and place them accordingly, and we adjust them accordingly. So I asked it if it should continue. The subsequent ones are going to tell it it should continue. But there needs to be another function that we have in the positioner. This is the actual spawn function. This has an entity, which is an entity. This one is going to be pretty much the same signature. So we'll call our own internal one first, and then if next positioner, we call its adjust position. With entity. So each one in the chain will then do the adjustment. So almost all of the prior stuff is last one has final say. And that's still technically true, but the difference is we don't override it. When we're adjusting position, we do them in sequence. Reason being is if we have a double spread, so a 10 pellet spread into a 10 pellet spread, that means that each of the 10 produces 10 more, but that spread happens from the position of the first spread. So let's say at one of them, let's do a a cross pattern spread. So you have up, down, left, right. The upper one will spread out from the going upwards. The bottom one will spread out going downward. So each of those spreads is influenced by the prior one. And hello, random. So this sequence should be correct. So then the adjust position is the thing that actually let's continue. We are going to change this to continue spawning. You to continue spawning. Okay. So spawn spawns on spawner path here. When adjust position is called, don't really pay attention to that, random. It is irrelevant. Viewers at any given moment during the stream isn't useful to me until after the stream when I review that. So then this one also needs adjust position. So for adjusting the position on this one, it's going to just say spawning is false. If it gets asked whether it should continue spawning, it only adjusts the position once. Where it could set the position to the starting point. No, it will not. It will not do that. It only cares about get position, and that's where we should start. It never actually adjusts it, because it is a spawn position one. Which means we can simplify this down to just we are spawning. So we set it to true once we've adjusted the position, once we set it to false. As far as this one is concerned, one path through is fine. This is... Where did we keep that? Is it a global node? Yeah. So when this one is asked to get position, it says, hey, whatever the global is. Subsequent ones generally only care when they adjust the position. I think we need to call this get spawn position. Then in spawner, we call get spawn position. So this is us asking the positioners, do you know where we should show up? Okay. Then, once we know where we can appear, we create the actual entity. Then that entity, as it's created, we're going to spawn it. Hello, Zachary. During this, the entity is going to get a target and a direction. So we actually spawn it, and this gives us an entity. Those unfamiliar with what we're doing, we are writing a game. We are in the midst of working on the projectile logic. How and when things appear and how they move. One of the goals of the game is to make it so that weaponry is modular. Instead of it being you'll still have a fixed set to start with, but instead of getting basic upgrades and then transforming like we see in a lot of them, you will be presented with opportunities to essentially attach and resequence a series of modifiers. So I might have a projectile that starts out firing in a straight line, but I could change it to where I might get an upgrade for it that says fire 3 shots in a spread. And then an upgrade that says make them move in a S-curve pattern when they travel. Then an upgrade that says make them home in. And both which ones I have and which order I put them in will greatly influence how the weapon behaves. And you can still have things like it hits harder the more you upgraded it or stuff like that. But a big part of it will be stacking those behaviors. So we spawn it, and then we're going to call positioner chain adjust position on entity. Okay, now we need another one for spawning. Spawn. Spawn on spawner path, spawn on player. Spawn on spawner path. Hello, Dylan. I think I recall you. You haven't been around lately, have you? Seems like a welcome back scenario. Factory dot. Let's look at our player factory again. I think we can have another nice generic function. Why did we make player factory a node? I know we made it a node for a reason. Oh, that's right. Because it's a node, we can go in and we can set these okay, yeah. Makes sense. Sorry, we made it a scene. It returns a vector 2. We're always passing in the player number, but for now we don't actually care about it because there is currently only ever one player. Now this is tricky because this is not correct. Like, if player 3 becomes null and I call any of these others, we have a problem. But for now, I'm not going to add that math. Making sure that I have some sanity check stuff. Well, Dylan, people have stuff to do, and that's, that personal stuff is more important than watching streams. Get that out of the way first, Okay, then in a player template, entity template. Oh, we need another spawn on position. Spawn at 0. Spawn at 0 is going to be useful for us because that's how players will spawn by default. So now what we need is another thing in constants. Okay, so we have positioner types. an undefined. Undefined is always bad, but we're going to set that up. Spawn on player, spawn at 0. Spawner path. Spawn on player. Yes. Okay, now we need a positioner pool. Positioner pool is going to be very, very similar to the movement pool. But it doesn't have a dictionary like that. It should only have a direct pool, just the positioner pool. Nope, that's wrong. We have 3 types right now. Spawn at 0. Spawn on the spawner path. Spawn on player. If you are having a problem of that nature, then I suggest you call your emergency services line, the equivalent of 911 in the US. If you are doing this as a joke, it is an inappropriate joke. So I would suggest you call emergency services and get help there. Coming into a stream and requesting this isn't a good idea. And that is why well, thank you, Zing. This is spawn at 0, and this is a spawn on path. Spawn player. Positioner get pool. Some arrays of positioners. positioners. That's a movement type. No, positioner type. It's not supposed to be a movement type. That. Okay, and then positioners need constant positioner type. This. Hello, Moonlight. Defined. I want this to just be positioner type. Constants, we have movement pool limit. Is positioner pool limit. For those new to the channel, we are making a game right now. We've been doing a lot of game development streams almost exclusively. We do also do gaming streams, but lots of game development. We are making a Vampire Survivors style game. Okay, so this should get us positioners of the types that we want. We will need this later. Release a shape. Oh, okay, that's right. It's because we know it's happening in a particular type. Yeah, shapes are trickier. Okay. Okay, we have positioner pools inside of our entity templates now. Positioners is an array of positioner type, positioner type, category, which is movement. How's the game going? It's moving along. We are steadily getting there. I think we're actually using the speed value anywhere, but we're going to keep it around just in case. Okay, so now we have an array of positioners. So we're going to go through each one of these. To set positioners, it's going to be spawn at 0 for the player. Call it the test blob template so I can remember that it's the blob template. The spawner path. Player. Player. Okay, so we've got all of those positioners set up. So now when we go into the spawner, the spawner is initialized with an entity template. We need to create the positioner chain. And that's going to be what amounts to an array. Range, which is going to be entity template, positioners, let's check this. Is this exclusive or exclusive? Okay, exclusive. So it's going to start at 1. Array of positioners. Positioner. Type in entity template dot positioners. Positioners. A dot append. So we need to go into our project, and we need to add a auto load for this. Pools, positioner pool. Open that. Call it the positioner pool. Create, and we need a type. Double check that positioner pool, and we're going to call create using a type. We're going to append that. So this is going to create an array of the length in order. So then we go through it, and we're going to start at 1. We're going to start at the second one. Which means if there's only 1, we're not going to do anything with it. Well, welcome back, and don't worry. Chain is equal to positioners. Okay, so the first part in the chain becomes that. Then positioners I +1 dot next positioner is equal to positioner chain current one. Okay, so we're going to get to the last one, and we're going to set it to the next position of the prior one. Okay. This should work. Do that. All right, what explodes? Oh, okay. It's because we're using that as a constant reference in the game. Test blob template. positioners. We initialize it. We make sure that we null out whatever the next positioner was. This becomes relevant. Because no matter what, when we get another one, we want to get rid of any data in the old one. So then each one of these should override initialize to call super and then call themselves. Zero spawn on player. Okay. And again. Nothing is spawning. All right. How did we break it? Step in. All into start spawning. We're setting spawning equal to true. I am making a game, Ski. Are making a game. While we are continuing to spawn. Okay. We're not continuing spawning here. The process is definitely interesting. So, continue spawning returns false. Oh. No, these are overridables, so... Oh, well, that's why. None of these override continue spawning properly. That generally be how it goes. Once it's done, it will be available in some fashion. We're a ways out from done, so distribution is not an immediate concern. And exposition. All right. So we have the basis for our positioning logic in place. We have spawn position. Our FPS is still holding up. Fun fact, base speed multiplier 1, is the same speed as these projectiles. So if I keep moving to the right, they stay perfectly on screen. We don't want to do that forever, but it's an interesting test case. Because it's not that everything, it's not everything overlapping that's the real problem. It's the fact that I'm piling up entities in general. The sine wave ones are never leaving the screen, this clot right here. Oh, and if folks don't realize, there are 3 streams going on right now. There's 2 on YouTube and 1 on Twitch. The 2 on YouTube, one of them is tall format, your 9:16, like on a cell phone, vertically aligned, and also a 16:9, so like a monitor or a cell phone held sideways. If you're on YouTube, the pinned message has a link to the other stream. Some folks prefer one way or the other. Yeah. Functional. Oh, that's not functional, though. Look at that. I generally prefer watching in widescreen, but your preference is up to you. Some people like Twitch better, a lot of people like the widescreen format, but they can't necessarily watch in that format how they're watching. Now, why did that break down the second time? Let's check our positioner pool here. In theory, it shouldn't matter. The Twitch channel is my user handle, newtmechanist. Same as the channel handle on YouTube, as well as it's the channel name without a space, you know? Let's look at our entity pool here a moment. We do need to add a shutdown logic to this to clean it up, but camera stops moving. There you go. Where do I have my shutdown logic? Been a while since I messed with that. Technically, a lot of this doesn't do anything anymore. exit tree. Okay, so this is shutdown logic. The player positioners, since the player is never removed, those positioners never leave. But we're always getting player 0. So we're reinstantiating the player each time. It's my own project, so it's not like a class project or anything like that. Okay, the game is continuing to exist, even though we've escaped out. Right there. If player, do all of these things. I have been doing a lot of coding recently. It's something that I decided to get back into. Escape, start. Okay, we have a fundamental issue here. Core gets the signal. It's supposed to remove the game screen pretty quickly. But since all the spawners get distance squared shouldn't be happening. So I press escape. I go to start. We are in collision zone. Isn't the base collision zone. But we should know if there's a player. Player factory. Get player. Then do these things. there isn't a player, then we don't check whether something's visible to the player. In fact, we won't draw anything. Start. Well, the first part of your name is Caramel, and I think we're going to probably be done there. If we have an entity, then we'll do stuff with it. And yours seems to start with rise. Escape start. Don't like that suddenly we're having to... Okay, so it exits the tree. Where are we? That's why. We only init the player once. If we remove the player, but this should be happening each time. Like, we create all our spawner templates. So I go in here, I start. We've created our player object. Spawners exist, collision is happening. I press escape. None of that should be happening anymore. But I start again, and suddenly I'm asking about the players collection, which now has another object in it. Oh. So we're going to need logic for handling the group of players better. Because right now, Player Factory always has, like, it always exists. Player Factory should be treated kind of like a pool. Subject doesn't need to exist anymore. Okay. This language, Bose, is GD script. It is a coding language specific to the Godot engine. I was saying earlier, you can use like C# and like I think low-level C interactions to work with Godot. This is a layer that works well at talking to Godot's physics, but since it's a scripted language, it's not necessarily as good at math. Not yet, Lunar, but hey, Lunar. I'm not going to reinitialize, but we're going to change this to remove players. So this should get us an error case pretty much right there. Spawning. Okay, there we go. Hooray! Very nice. We do need to account... the game does have a story. It's kind of in the background right now, Bose. A lot of it originates with, like, the origin of my character here. Some of the imagery and, I mean, the background of my character here starts way back with a Noida mod we made. Lunar was actually there for a lot of that. Okay, we have spawn positions created now. Tile map updating. I don't know that you were here for the last time, Lunar, but we have the yarn ball weapon in. That's right, Bose. I am the proto-Nyanite, the first in the new line of products by Catbot Corporation. So we have the homing mouse, we have the yarn ball, we haven't got the laser pointer in yet. Laser pointer is going to be an interesting thing because that is, when it comes to sprites, if I want it to have a travel time, if I want it to be hit scan, that's not too hard. It's a completely different process since it needs to know the point of origin that the projectile had. And it needs to know where it has ended up, so I can just draw the line. But if I want to be able to have a graphic of the flow of the beam, then you essentially need to smear it. You could render it multiple times as well, but it amounts to rendering it multiple times. So you have things like a begin of beam, end of beam, that kind of thing. That's right, Karuru, the nanotype. The follow-up product to the catbot. And you can't see it terribly well because the yarn keeps getting in the way, but the sprite in the center of the screen is a catbot. You can actually see it in some of the earlier streams I did. A ways back, but I do have earlier streams on my channel. Shameless plug, look at my earlier streams. Where the avatar that you'll see is the catbot instead. Oh, but we're just seeing preliminary graphics for a lot of this. Character lore and the like will become more and more apparent as far as the in-game stuff as we progress further. Catbot Corporation denies any allegations related to any sort of robot uprising or sentient takeover of the Catbot factory. Everything in the factory is working as expected and as it always has. Catbot Corporation denies any sort of hostile actions from the nanotypes and considers those statements defamatory and actionable. Any commentary related to words such as bunker or weaponized are entirely false and sensationalist efforts by the mainstream media. Fake news, as it were. Okay. Now we need to work on positioning of sprites or of projectiles. I think what we need is a testing one that is essentially to adjust all projectiles to aim up when they are created. Lunar, that's actually kind of the goal, is I want weaponry to start out reasonable, but if you manage to last long enough and get the right combinations, I do want them to be bonkers. I am trying to optimize performance to an extent where that will take a while to get to. But the idea of, 5 projectiles that chain into 10 projectiles that impact and spray 10 more projectiles in a circle is the kind of thing we eventually want to get to. So that the weaponry that we get to see is often needlessly flashy. Because a big part of this will be trying to reach that state. Because it won't be a matter of get a weapon, get its upgrade component, and that weapon becomes very powerful. It's going to be a matter of you get a weapon, and then if you build it badly, it's going to stay a bad weapon. If you build it well, it gets OP as all get out. At least that is the goal. That is what we are working towards, for the most part, right now. Each time it remembers its direction to use, but that direction to use is only remembered by some things. Yeah, more along the lines of Noida or bioprototype. I want to be less restricted than bioprototype is usually. Bioprototype can let you get out of hand, but there are a lot of constraints on how out of hand you can get. For the most part, what we're looking at with this is to some extent like that linear chain, but there will be no, like, you can only have so much power kind of vibe. Okay, so we have positioning. Let's look at our spawner again. So we go through, and now we adjust its position. It spawned, so it has its initial position. But part of our difficulty here, we no longer care about moving away from the player. I'm sorry, we aren't intrinsically moving away from the player. If we want to move away from the player and spawn on the player, or any sort of movement that says move away from the player, should always have a nudge in velocity if it doesn't spawn right in position. So, if an object says I move away from the player along my line of direction, then only its velocity is influenced if it has a direction. If it doesn't have a direction, it would need to randomize it. So because we don't need that, we're going to do a quick test here in the entity. What we're going to do all the way down here, we set up the movements. Here is where we're initially calling it. This will predetermine how it all works, and this will mess with our ability to influence that initial direction. But we need that initial target. Right, Lunar. If something says all it says is move away from my point of origin, but it has no direction to move in, it would need something to get it going. This is a good opportunity. Let's switch over to CatCam. Let's see who we can see. Well, there's nobody on camera one. Okay, so we have Ember is by the desk side. She is the third camera or the upper right camera, depending on which view you're looking through. Sky's up in his tree, and Mason and Sherbet are on the bed. Sammy is once again off camera. Switch over to this camera here. I have 5 cats total, Cat. And 8 cameras with which to find them. I may have references to all of my prior cats. And no, Bose, the cats on camera are all living cats. Living cat research is a critical part of the Catbot Corporation experience. I found myself that 7 cats was very difficult to maintain the level of affection that I would want to keep giving all of them. 5 so far is pretty good. I think if all of them were as snuggly as Ember and Sammy get, especially Sammy, there could be a problem. Kind of Sammy and Ember are definitely snuggly. They like to get in there, and they like to sit in the same spot on top of me. Mason is snuggly, but less so, and Sky even more, or even less snuggly. Sherbet's a strafey cat. If he wants attention, he'll jump on the headrest of my chair. Not a dog person. Not a dog person. So we have to get... We need this. We need this for the first entity. Once we have this, every subsequent entity is going to have this value adjusted before this occurs. Okay, so we call the first one. We get this. All of the movement entities, all of the positioners need to have this value passed into them. Okay, this is where the positioner chain starts over. Right here, right after the entity has spawned, is when we need to get that initial position. Because all subsequent positions are going to be influenced. Oh. We're heading into the hard part of positioning logic. Bose, I get my music through Epidemic Sound. In my YouTube videos, I haven't updated my Twitch page in a while. I probably should get around to doing that. But in any event, in the descriptions of my YouTube live streams, there are links to playlists that I get through Epidemic Sound. I select the music myself, but all the music is from there. So again, we need an initial position for the first entity to be spawned. This part of the cycle right here. So until we spawn something, we don't know what that value is. So we get it the first time. And subsequently, when we call get position, get spawn position, where are we doing that? Welcome back, Dylan. We call get spawn position. We don't care about that. It's only when we adjust an entity that we now care about that. We're making a Vampire Survivors style game, Dylan. As I was discussing earlier, the weaponry will be more akin to games like Noida or Bioprototype, but general gameplay concept is, the Vampire Survivors model. Though if I, by mentioning Bioprototype, it uses a Vampire Survivor style model too. So more like Bioprototype, but fewer people know about that game, I think. On that note, they're making a sequel to it already. The first one was not bad. So we're going to get the spawn position, and then we're going to call adjust position. As soon as we call adjust position, we know what the direction is that it's planning to move. I haven't done Monster Hunter streams in a bit, Dylan. There was a disruption in the availability of other folks. That's not to say we won't revisit it. I mean, they're putting out a lot of stuff about Monster Hunter Wild, so the itch to do so, to do more Monster Hunter, might bubble back up. Though we had reached the Guiding Lands, and the Guiding Lands can get a bit grindy. Like, there's not a lot of new cool stuff to do. And the raids aren't always terribly interesting with a limited pool of people. The raids are really oriented towards going into public lobbies. And, pun aside, Bose, I am really interested in some of the stuff we've been seeing about Wilds. There's a lot of changes to the core gameplay assumptions being shown in Monster Hunter Wilds that I think are for the better. Even if there was nothing else, I think the only remaining thing that I would want to see, if we just took what we have seen and we extrapolate that out to the rest of the game on top of basic like Monster Hunter World style gameplay, great. But what I am hoping to see is a removal of the item system for bowgun and bow ammunition. I'm fine with different guns having different ammo types and different qualities of ammo types, but the idea of carrying the bullets and crafting them on the fly is both archaic. It's an anachronism from the early games where they actively set out to penalize you for using ranged weapons. Like, they intended to make them clunky to use, and cumbersome in general. If they remove that and just balance them better around movement, reload, kick, all of that stuff, then that's amazing. On the plus side, based on what we can see, I'm not seeing much of Rise at all in it. I mean, we do have the obvious increased mobility of the Secret, but one, I like that we're not seeing that it is replacing the Palico. Combat is much more of a utility device than an active participant. As in, calling the little riding lizard over to pull you up on the saddle to pull you out of a full knockdown kind of stuff. That sounds cool. That is a this entity is another part of your move set as opposed to an independent entity. Because again, we've already got that in the Palicos. The Palamutes felt like both a duplication of existing functionality on top of being a feeling like you were compelled to overwrite the existing functionality. As in, the Palicos couldn't let you missile yourself around the map as easily as a Palamute would. And that's not good. Now, visually, Wilds is absolutely not Rise, and in fact seems to have looked at World and said, hold my beer as far as area design. Because the areas seem big and open. I'm liking that it seems as if they're leaning more towards hunting mechanics as opposed to just the arena punch-ups that we've gotten before. The idea of having to lure a single opponent out of a herd using the environment and your mobility, that's very cool. At the moment, things like traps and similar are entirely either a damage spike, a damage spike or a stun. And that's kind of boring given the whole gimmick. Like using a trap to block escape kind of thing. No idea, Bose. I only recognized there was going to be a trailer because I saw it get posted. I tend to try to avoid being too on top of the hype train. Like, I like to hear about it, I like to know, but I also don't like to anticipate the next car in the hype train. Because hype trains already happen often way too soon. Like, we're like, what, a year out or something like that from Wilds? And while I am excited for it, I don't need to be perpetually excited for it. Okay. So when we adjust position, we're getting an entity. If we store off the movement that came in, then on subsequent calls into movement, we can pass that in when we're creating the entity. So when the entity is spawned, normally we have target direction here. If when we create it, let's see, let's find target direction. Okay, so the first time is during initialization, and then subsequently on movement, we update it. That's fine. Updating it is fine. Okay, so it's only during that initialization that we set it. But if it's already set when we pass it in, then we can influence that. Yes. I try to remember to save regularly, and after each stream, I do a branch commit. Hello, Tabby. Okay, so we've got the direction. We call into adjust position. We need the direction first, and we're going to adjust it after. So if we instantiate the entity and we put in that information, we then adjust it accordingly. Yes. So in a positioner, initial direction is a vector 2. We're going to 2.0. No idea, Dylan. Let me see. Is anything flaking out here? Let me take a look. Nothing seems to be exploding, so hey, that's good. If not initial direction, then initial direction is equal to entity.target direction. Okay, so then subsequently, we know what the initial direction is on all later calls. And we could adjust it accordingly. So what if we rotate we could make this so that it always curves left, but what we want to do is get our proof of concept for the spread shot in there, so that we're always passing in a new direction. We're going to need to make sure that our targeting logic doesn't override fully. Oof. We're going to need to revisit our movement logic, our movers, to make sure we can do this. So some movers should say, I received a direction in initially, like the first time I moved. So subsequently, I'm going to force that. Oof. So when we actually spawn one, and we get an entity back, during this initialization process, we need to be able to create it and set the target direction of the movement before we initialize the entity. Zerto. Okay, if we pass a target direction into the spawn, then we will also pass target direction into here. That's not going to like that because entities don't take that value. Or 2. Replace U in the same way. I do see that we have somebody raiding on the Twitch side. Welcome, raiders. Joining us for our game dev stream here. We're running a bit long. We're trying to get our weapon spawn pattern logic done. But yes, welcome, raiders. Welcome. Well, thank you, Blueberry. Here. Since we got folks coming in, let's show off a bit. These are the cat cams. There are 5 cats. I have 8 cameras to try to track them. We can see 3. Sky is up in his tree. Mason and Sherbet are on the bed. Ember is sitting on my lap getting back scratches, and Sammy is not visible. She has a couple of spots she likes to sit that are off camera. So yeah, the cat camera down there is a live feed, and I can switch it around to try to find the other cats. I usually try to keep it on the most cats at once. To use. So if we pass in a target direction, it will assert that in the subsequent functions. Then it will be dependent. Then we're going to depend on those movement types to respect it or not. Ideally, they will when they're randomized. But if they're the type of movement that doesn't respect incoming movement, then it doesn't matter. So like positioners. So if we space target, should have a targeting down here. Random direction. If direction to use, save direction is equal to direction to use, else if not saved direction. Put an explicit not in there. I'm coding a game, Blueberry. Did I break it? Let's find out here. So we're making a Vampire Survivors bioprototype kind of game. A lot of placeholder logic going on here. The sprites that I have are going to be actual sprites, except for the background. The background is placeholder is all get out. What we're demonstrating right now is how the projectiles behave. So for one, I can recolor the projectiles, that kind of thing. The spiraling ones are the base color of the yarn. The ones moving straight right are dyed purple, and the ones moving in an S-curve are dyed blue. But all of these are the same general projectile. This one is actually being told to move right at 1/4 normal speed, 4 times. This one is being told to move right at normal unit speed, but it's adjusting its movement to be this S-curve. So its right to left, its left to right movement is actually the same as the purple one. So you can see how the blue one keeps intersecting its corresponding. Like, this blue one always lines up with this purple one. Then the spiraling ones are moving to the right, again, at half a unit, and then the spiral is expanding at half a unit. So its right to left, left to right movement speed, keep saying right to left, is still the same as the purple one. So you can see the pink ones hitting a corresponding purple one every time they come down. The idea is to create, instead of weapons having a fixed upgrade path, the weapons start out in a particular way. So there's a wind-up mouse that you're not seeing here. Oh, here, let me just show you the wind-up mouse. We'll go to... Let's go to the S-curve one, huh? Let's move to the right. That one is S-curve. Okay. And instead of yarn ball, we're going to use wind up mouse. And we'll remove the color modulation from wind up mouse. So there's wind up mouse. So I can make them look however I want, but for example, in the original Noida mod, where a lot of these sprites are from, I had a mod for a game called Noida for a while. You can see it in my older streams. Shameless plug, look at my older streams. The wind-up mouse was a homing weapon. Nobody liked to use the homing weapon. Because the yarn ball hit harder and the laser always hit. There was a red laser pointer, a wind-up mouse, and a ball of yarn. So let's say the homing mouse always homes in. Like, that's its base movement type. But there'd be nothing stopping me from saying, well, it homes in, but it moves in an S-curve. Or, but it moves in a spiral. Kind of things. So those sequence of upgrades, how I plan them out in a line, would impact it. What we're working on right now is being able to say, well, it's the wind-up mouse, but it appears at a random point on the screen. It's the wind-up mouse, but it fires 3 at a time in a spread. Or it fires 4 at a time in a cross pattern kind of thing. We can see that with the yarn ball. It's the yarn ball, but it moves only to the right. It's the yarn ball, but it moves to the right and it spirals. Those kind of things. That's what we're trying to do. We're working on the but it's in a 3-shot spread part. So we've set this in here. Now we're going to do we have spawners. We're gonna do this. It is a positioner. I need to see if I can make a template for positioners. Yes, we will eventually get it to where, like, after a timer or when a projectile hits something, it creates even more projectiles. And those projectiles have their own way of spawning, kind of stuff. The goal is to eventually make things so crazy complicated as far as how movement is happening that. So the core flow of the game is generally going to be that you either get wiped out because you get swarmed, or you become so increasingly powerful that you get nuked, and that ends the run. Like, there will be an absolute end condition to the run, akin to what we see in Vampire Survivors. Even if you kill the Red Death Reapers, eventually the White Ghost will appear and end the run. You know, barring an endless mode. Which is not off the table, it's just not the starting point. Hello, Peb. Peb is as far down that name gibberish that I'm getting. Pretty much, Lunar. At the end mark of the run timer, you get ICBM'd. Okay. So we're going to take all the logic to spawn at 0, and we're going to put it in here. I also want to have a kind of a mood shift, an atmospheric shift as the run continues. So, in addition to an escalation of foes, the perspective of what you're doing should change over time. And that's both going to be represented in the opponents that you see, that escalation of threat, but even things like health refills and where you get free power-ups are going to shift over time to change the tone. Should be neat. In the future. Right now, we're just trying to make bullets spawn. As a int to 0. There's a reason we're doing it this way. spread pattern is going to be something that I can make multiple instances of. I may come up with a different way to do it, but for now, because there's a function here, a child of pattern spread could override this function and replace what it returns. I want to have a different way to do this. We're probably going to have templates for them. But even with templates, that would be a meta value, which is messy. Meta values on objects and templates being the in-engine name for something that's going to break inevitably. All right, so with a spread shot, what we've got is we've got a direction coming in. In our base positioner, we have an initial direction. This is going to be what we're going to base our spread off of. So once we've got that initial direction, we're going to take that, we're going to divide the, let's say, a 90-degree arc off of the player into 3 equal segments. Once I've got all of this kind of stuff done, then the wand building just becomes a recreate the weapon with this pattern instead. So as far as the player is concerned, it's going to be sliding blocks around, you know? Oh, that's right. There was a... Parakeet suggested a 2D platformer that had a Noida-like weapon generation too. Super, we're having a good day so far. We're having a good day so far. Good enough day, in fact, that we're running the stream later because I feel like things are rolling, you know, we're making progress. I haven't reached that point where I've practically concussed myself on by bashing my head against a problem. It's a rare situation. Gotta take that kind of thing when you can and run with it. Zero divided by zero, that'll make a problem. So when we initialize, we set spawning to that. We set bullet count to 0. Spread angle. I don't know, spread angle will always be the same. Spread angle wouldn't reset. Knit. Okay, so the spread arc. Well, thanks, Blueberry, and thanks again, Raiders who came in. Always appreciate it. Good to see new folks. Okay, so the spread arc is going to be where they're distributed across. So if it's a 180-degree spread arc, then we're going to make it so that spread falls within the forward 180 degrees. So it will be divided into those slices. So essentially, we're going to divide it into max bullet count. Max bullet count +1 segments. So let's say it's 180 degrees. We're going to divide that into 4 segments, such that the bullets are sandwiched between 2 of those segments. So it would be 45-degree segments in that case. So, we would have at 45 degrees, at 0 degrees, and negative 45 degrees. I think that would actually be in the reverse, negative 0, 45, as far as a aiming right by default. So what we're going to do is during the initialization, we're going to configure our spread angle is equal to spread arc. We don't want to keep calling functions. We don't need an end angle. We should start angle. Okay. Earns an int. Earns a float. Force it to be a float just in case. Actually, set spread arc, set spread angle. Integer is equal to 0. Max mullets. Hopefully 1. Some sort of dread mullet turducken being created, I guess. We're going to do it this way for a reason. Just a moment. Set spread angle. We don't need to set the spread angle because we know what that is. And that is... We're going to keep these, but we don't really need to keep them. We're going to do it anyway. Spread arc divided by X bullets plus 1. Hopefully this will come through correctly. We need to keep an eye on this and make sure that this doesn't get integered. We don't want it to drop the decimals. Start angle is equal to -1 times spread arc divided by 2. So if it's a 180 degree spread arc, then half of it is 90. So you have 90 degrees. -1 says, okay, we're going to start at the negative end. And we're going to iterate from there. So we're going to go -90 to 90. Let's keep it that way. So this is how the reset happens here. Is bullet count becomes 0. Explicitly set it there. Hello, Garrett. Welcome. We initialize it until it starts spawning. It is currently spawning. No worries. Monday I don't stream, so you didn't miss a stream. initialize resets it. So we're going to set bullet count there. Start spawning resets it. If we need to know if we should continue, bullet count is less than max bullets. Get spawn position should accept a vector 2. Where a higher up one can override it. Oh, no, we're already doing that. It does not override spawn position. Huh. I wasn't aware that there was a Newt character in that. I always found Newt to be kind of a neat name. At least since it was used in the Aliens movie. Looks like we're getting some network interference, so hopefully the stream quality isn't plummeting for you. Entity. To I'm aware of the movies. I've never watched them. They're based off of books, aren't they? Similarly to the Hunger Games ones, you know. YA book series that took off and got movie. So I do bullet count plus equals 1. Goal to use equal to as a float is equal to start angle plus spread angle times bullet count. Equal to target direction rotated degrees to radians that. Okay, so then in the spawner, during a tick, so an interval has begun, we're going to say while continue spawning. And we're going to cross our fingers that this doesn't cause an infinite loop and break some stuff. It's 4 move rights. We don't need 4 move rights. Can I teach you how to code? Not directly, but you can see a lot of the coding processes and what is required by watching the streams. And as I've said previously on prior streams, this is a mutual learning experience. It's either you can watch and see how somebody, like a person like me, codes. Maybe you'll decide to do something along with us, or you'll do something on your own after having seen this. A big part of learning to code is actually just doing it. You can be taught things, but the things that you're most likely to be able to be taught are core concepts and theories. So otherwise, the thing that you would learn would be how to use a particular tool, and that ends up often being do exercises, code using that tool. So while learning things like algorithms and data structures, reading papers on coding practices is stuff you can do, just getting out there and coding is going to get you a great distance along the path. Okay, so now we need a positioner. So this is our spawn on. Then we're going to do a different one. We need to go into our constants, and we're going to add another spawner, which is a pattern spread. Just so. And then in our positioner pool, thanks for joining us, Dylan. And yeah, it's practice, watch videos, try things out. A common thing with game development that wards people away is they'll look at something, like initially they look at games and they're like, oh man, I love games, I want to do that. So they look at it and say, oh, but I don't know how to code, I don't know how to use Unreal Engine, I don't know all of this stuff, I don't know how to 3D render. All of those things are things you can learn to do. You can get Blender, you can get Unreal Engine for free, you can do all of that stuff. Look up some videos. You know, get yourself started with a gaming hello world. Pretty much, Karuru, it's a just do it. Start working on it. That will accomplish two things, is you'll get experience doing it. You'll start learning where you're making mistakes, learning new ways to do things. Additionally, it's an opportunity to learn if you like it or not. That advice applies to a lot of stuff. You might look at something and say, oh man, it's super cool how these people are doing pottery sculpting or painting or something like that. And you might start doing it and realize, while it looks cool when they're doing it, I don't like actually doing it. It's not fun to me. And if you started out with a small investment, just like, hey, I got the bare minimum to get started, you haven't burnt resources on it. Like, your first game project should not be Star Citizen. I think the people making Star Citizen should make their goal to complete Star Citizen. That might actually make it so Star Citizen gets done. But you don't start there. You start with, like, Pong. You know, baby steps. Reload the project so it gets those. Moving along, Maximum. We're moving along. We've got spawn position working, and now we're going to test spread shot. Oh, coughing. Okay, so we need the entity here. Our yarn bolt that is just moving right. We want pattern spread. I think this is session 45, so about 135 hours. Probably plus a handful of hours for offline stuff. Okay, we're going to limit ourselves down to just template 3. It do be like that sometimes. Okay, so we're just spawning the ones to the right. We look at template 3 just to be sure. We have spawn on player and we have patterns. So now we're going to go into our spawner. Oh, that's right. Okay, we're going to change some of this. We're going to use target random direction instead of move right. I don't know if I set it, but hello, Panzer. Okay, so now we come in here. So target random direction should come in and say, I have a direction to use. Let's verify that we're actually leveraging that. We spawn it. We've got position, direction to use. Get onto spawner. again. Target random direction isn't really what we want to have happen here, but... Or this isn't really behaving how we want it to. Okay, so half second passes, we come in. We say start spawning. Say, well, there's it says to continue spawning. And continue spawning is that we have fewer than max bullets. Spawn one. That's not right. We only spawned one. Oh. We start there. Okay. Oh, steps right out. Call into adjust position. Spawn on player says do nothing. Okay. It's not being configured correctly. In positioner pool, we call initialize on it after we get one. Should be in here. We initially create a spawner. Entity template. Over it. Okay, this is the yarn ball. We create two. So our positioners have two things. Object here, object here. We go in and we have the size of 2. So we're only going to do this for I is equal to 1. So if we look at spawner, we look at our positioner chain. Next positioner is null. So there's our breakdown. Put a pass here so I can breakpoint that. Positioners, iterating over it on 1. Oh, -1. I don't. I minus 0 is not a helpful bit of math to be using here. Spawn on player. Okay. We start spawning. We go in, we spawn it, we call adjust position, and we immediately step out. So first we go in and say, is there a next position? There is. We're going to ask it if it should continue. Should continue is true. So we return true. So we go in here. Figure out where we get the spawn position. And this is spawn on player, so currently it's 0, 0. So we spawn it. And we call adjust position. So we do our adjust position. That does nothing here. And then we go into the next one. This one is going to adjust position. Oh. Okay. It's backwards. It's backwards. No, this is correct. Hello, Javier. Welcome. We create it. We start our chain with the first one. The first one, in the case of our template here, is spawn on player and then spread. Oh. Again. Not quite, but we're getting there. We're getting there. So we're going to go into the game logic and we're going to slow that one down. Two seconds between them so we can fully see it. Okay. Okay, now I should have positioner. When I adjust position, I should have an initial direction. Okay, so let's say 8455. 8455. Are you asking how many subs I have? That information is available on the channel. To use is 45. Yup. 45. Gets a direction to use in. First one steps in. Has direction to use. Oh, wait. It's not getting a direction to use, so it generates it. And save direction becomes 9726. Okay, direction to use just did not get passed in right there. So we're not passing in okay, so when we spawn it, we're not passing in that value. So I'm going to do positioner chain dot initial direction. And then in a positioner, its initial direction gets zeroed out each time. But target random direction is created tricky. Okay. So the problem is when we the positioner chain remembers that direction coming in. The entities all get that position, but that means that subsequently there are things that ignore it. So if we look at target random direction, so if we have a direction to use, we use it. Then else if save direction not save direction, we come up with the save direction and we pass it along. But if we get a direction to use, we're going to keep it. Okay, they shouldn't be moving that fast, but okay. In the spawner, our initial direction should always be normalized during the positioner process. So still rocket propels them, but we're off to a good start. There's like a multiplier being added to it here. This will always return the normalized direction. There we go. This isn't quite what we want to deal with, but it's happening every time is the trick. So when we spawn them, we're getting positioner chain initial direction. We loop back around, we're done. We've spawned 3. Call through each one. We start spawning, we need to 0 it too. This clears that out. Nice. So what we've got is we have random directions spawning and we have a spread of 3. Okay. Then yeah, move right is a hard override, so that doesn't... We can't use that one. We could use move facing, where it'll accept what you give it, but spread from there. But we do need to find a way that we can adjust the position. So that when move right comes in, it says, okay, you want me to move to the right, but you also want this change to the position. Because the spawn has to happen right away. Alright, well, let's look at entity 3 here. We have random direction, move straight line. So we're going to add an S-curve here. S-curve is easy. That's acting much more like a spiral. Because it's accepting it all coming in, always. So once target random direction gets a direction, it reasserts it every single time. So we still need to cascade down. But if we don't So we need to be able to do this. We store them off so that we can do the initial movement. Then during a move, we do this iteration again. But we clear the target entity, the target direction. This is not correct. All right, we are going to going to force it to move right and make sure this is working. Okay. Let's increase the speed of the S-curve. See if we can have it be more visible. Okay. That's working. I like. Really wiggle here. I like that. But if we tell it to move right here, this is where things get a little trickier. They entirely overlap if it's a fixed direction. So if we're not supplied with a direction, we could keep it. If I had the idea of targeting right, but instead of move right. What if... Progress is being made, Tess. We're just about to wrap up for the night here. Spiral is acting a little weird here. Let's have the spiral move pretty quick, but let's have it move right pretty slowly. We are also on Twitch, Skia. It's very weird. Oh, move straight line actually got increased. I primarily stream to YouTube, but yes, right now that delay, it's... So this is a spread, so they all come out at the same time. I want to add a little bit of a frame delay, like a processing delay between each projectile to ensure that we don't get a problem. So if I go into my spread logic here and say we're going to spawn 20 of them. I mean, for one, it kind of looks cool, doesn't it? It is kind of neat. It is kind of neat. Okay. 50 at a time. This would have made it lurch before. We're getting a steady 60. There are 50 yarn balls moving right now per pulse. I like the little undulating wriggle they get at some intervals. Well, thank you, channel. Thank you. I appreciate it. Well, here, it's a good opportunity to show off a bit. How many can we see? We've got 4 out of 5 are visible. Ember, you could see previously we have Sky up in the tree, Mason on the tan blanket, and then Sherbet is hanging out on one of the heating pads. Then I always like to do this. There you go. it can be fun to show off. All right, all right. Let's push our limits. $100 bullets at a time. Now, we may hit the problem if we hit 3,500 here, it will start lagging. But wow. I didn't think this would work this good right away. So this is random direction, spiraling, and I think we're moving in a straight line too. Here, let's I mean, the enemies are going to last all of like 2 seconds, but you can see the happy little blob spawning. Because those little waves will just scythe through any number of them. Oh. Now, granted, they've got to be hit by them. Channel, we're making a game. I am going to be doing some more gaming streams lately just so that I'm not over, like, burning out on this. But we have been setting out to make a game. This is stream 45 of the game dev process. I do a little bit of research and sometimes code cleanup offline, but it's all been happening on stream. So about 3 hours every stream day, upwards of 5 times a week. Ish. Did we hit a spawn threshold with one of them? I think we did. Right, let's do some more weirdness here. Okay. They're going to move at rotational speed 5. Yom. Coding is a practice thing. Just like any sort of like math or writing or any skill whatsoever, cooking. It's both you learn by doing, and you also learn by maintaining your memory. Like, if you don't do it for a while, you're gonna lose practice. But just like the old saying, you know, actually, I don't know what the old saying is. It's something about riding a bike. You know, you don't forget how to ride a bike. It just takes you a moment to remember how to ride a bike. With coding, it's like if you haven't programmed for a while, you learn how to program again. And the more often you've done that, the more often you've been coding over time, the easier that memory is to restore. Another way to do it is, if you want to learn to code, if you want to learn to make games, start making games and start coding. The bar for entry is really low. Most of the tools are free. If you've got access to a personal computer, you can get going. Now, that's assuming you actually want to. You know, it's not a you have to kind of thing. Look at him go. I feel good about this. We've made progress tonight. If we remove spiral motion here, so we've got move straight line. Let's actually put move straight line back into the running with a speed of 1. Oh man, look at that. Look at that. That's extra neat looking. It's all wiggly. So what's happening is it's choosing a random direction. It then takes that random direction and it does a 180-degree arc off of it. It subdivides that 180-degree arc off into the number of projectiles plus 1. So about, 1.8, a little less than 1.8 degrees per projectile. There's 100 of them spawning at once. It spreads them out across that equidistantly and then sends them on their way. It takes that straight line motion. Each of them are fanned out, so it spreads them out. That's why it's widening. They're each moving along, and along that straight line path that they've been given, they're also spiraling out increasingly fast and wide. So if we really want to see some weirdness, we're going to change the scale of the spiral. So it's still spiraling around really fast, but we're going to make it so that the spiral grows slower. So you can see it's kind of wobbling along its line more. Sometimes you just gotta roll with it, So this is the spiral growing really slowly. Let's put that at 0.25. We're going to make it move in a straight line slower as well. That is also a possibility there, Lunar. Right now, the spiral can only grow, but having a speed modifier is something that I want to do, such that there is a modifier that happens before the spiral that is going to adjust the speed and scale of something that is following it. We don't have that concept in yet, but man, look at that. We got some Windows screensaver action going on here. But right now, the scale and speed of a modifier is fixed. Of a movement type. So the spiral, a entity that is attached to the spiral attached to the entity has a set value there. Relatively lore appropriate channel. Alrighty. Buttons. Well, I think we'll wrap up there. We went for an extra almost 2 hours tonight. But we've got to wrap up before we'd have an extra hour that we would hit our threshold on, but we just got to be careful. Otherwise, YouTube shenanigans can happen. Oh, but I want to thank everybody for joining us tonight. I hope you had a good time. We had some nice folks rating us over on the Twitch side, and we've got a lot of new faces that have swung through on YouTube. If you like what you saw and would like to see more, remember to like, follow, subscribe, comment, all those good things. They help the algorithms give you more of the same. In the meantime, I do hope you have a nice rest of your evening. We will be coming back tomorrow. We're going to try a new game called Duck Detective. It looks cartoonish and cute, and I'm hoping for another game with the sort of fun detective vibe that we got out of For Your Tranquility, but maybe a little less intense than that. All right. Once again, hope you have a good rest of your day.